So we are going to be looking at section 5.2.1, which is finding the inverse of an exponential function. So far we've looked at finding inverses of various functions, but not an exponential. At this point, we've kind of gotten stuck and said we don't really know what the inverse is. So we're going to start off, our classwork assignment is going to be 55 through 58. So I'm going to kind of walk you through the lesson. So you'll need to push pause at various times to complete the independent work. So we'll start with question 55. So it says, so far you have learned a lot about 8 different parent graphs. So if we look at these graphs, we have a parabola, a cubic, a line, an absolute value function, a square root function, a rational function, exponential, and then we have a circle. So for each parent, you are going to find the inverse if possible. So remember to find the inverse. In this case, y is already switched from f of x. So all you would do is solve for x and then switch x and y. So you're going to find the inverse, write the equation in y equals form, and then you are going to sketch the parent function as well as the inverse function. So I would recommend using 2 different colors, or maybe do the parent function in a solid line and then the inverse function in a dashed line. Okay, so you guys will go ahead and do part A, and then for part B, it asks, are there any parent functions that are their own inverses? Explain how you know. So what that means is when you graph it, or when you find the equation, it's exactly like the original parent function, and there possibly will be some. And then lastly, it says, do any parent functions have inverses that are not functions? So remember, the easiest way to tell if something is not a function is by doing the vertical line test. Okay, so go ahead and do those on your own right now. So go ahead and push pause, and then we will come back and look at that. Okay, so you should have completed 55, A, B, and C. So for 55A, you can go ahead and look at the answers posted on my website. For part B, it says, are any parent functions their own inverses? The answer is yes. So you should have gotten that the line, the rational function, and the circle end up being exactly the same. This can be seen by the equations, or it can be seen in the graphs. And then part C, do any parent functions have inverses that are not functions? Yes, so a parabola, when you find the inverse, it turns into a sideways parabola, which is no longer a function. And then the circle, it turns into a circle, which we already know is not a function. Okay, so for question 56, we're going to go ahead and do this one together. There are 2 parent functions, so y equals the absolute value of x and y equals b to the x, that have inverses that do not yet, or that we do not yet know how to write in y equals form. So we could possibly graph these, right? We could just switch the x and y and then go from there. But they're saying we don't know how to write the actual equation, and that was kind of your task for 55. So you will come back to the absolute value equation later. And since exponential functions are so useful for modeling situations in the world, the inverse of an exponential function is also important. So you're going to use y equals 3 to the x as an example. Even though you may not know how to write the inverse of y equals 3 to the x in y equals form, you know a lot about it. So when they say you don't know how to write it in y equals form, that's true, right? We can switch it and we can say x equals 3 to the y, but we generally always want to write our equations in y equals form if we can, because when we graph them on a graphing calculator, they have to be y equals form. All right. So for part A, it says you know how to make an xy table for an inverse of y equals 3 to the x. And then it says to make the table. Okay, so we will go ahead and do that. So what I have here is my table for 3 to the x. And what I want to do is write the table for the new inverse function. So to do that, really, we just switch x and y. So it makes it easy when you already have the table written out. So this would become 1/9 -2. This would become 1/3 -1. And then 1, 0, 3, 1, and 9, 2. All right, so there we go. So there we have our table, and that's actually part A. I should have written it there, but that's okay. So all we did was switch x and y. And then for part B, we want to then graph this table. So I should have done a little bit more labeling here. Okay, so we have 1/9 -2, so pretty much almost to 0. And then we have 1/3 -1. We have 1, 0. We have 3, 1. And then we have 9, 2, which I'm not going to worry about graphing. So when you look at this, it kind of looks like an exponential function, but on its side. So if you like rotate your head to the right, it looks like an exponential function, which makes sense because it's the inverse of an exponential function. So that's for part B. And then for part C, it says you also have one way to write the equation based on your algebraic shortcut that you used in part D of problem 5-40. Write an equation for the inverse even though it may not be in y equals form. So to do that, that should be, we kind of already talked about it, it would just be x equals 3 to the power of y. That totally makes sense because that is what our table is based on, right? If I do 3 to the -2 power, which is my y value, my x value would become 1/9. So I'm just switching the inputs and the outputs. All right, and then for part D, it says if the input for the inverse function is 81, what is the output? So let's go ahead and look at it. So if the input for the inverse function is 81, what is the output? So it's saying 3 to the what power, essentially, right? 3 to the what power is equal to 81, because technically x, right, is always our input, y is our output. So in this case, we can just kind of use reasoning. 3 to the 4th power is going to be 81. So it's the exponent you raise 3 to get 81. All right, so let's go ahead and look at 57. So 57 is now coming to the idea of logarithms. So the reason why we have these is this is actually how we are going to write the inverse of an exponential. So it's going to first have you look at these four log equations and figure out like what is the pattern. So I'm going to let you guys do that on your own, and then you will come up with A through F on your own as well. So you can go ahead and push pause and do those problems, and then we'll come back together. Okay, so you guys should have done 57 on your own, and we're going to just lastly do 58. And remember, you can check your answers on the website. So 58 says, how is the ancient puzzle related to the problem of the inverse function y equals 3 to the x? Well, I kind of gave it away already, but right, the inverse of an exponential is a log. So how we want to show how we can use the idea of the ancient puzzle to write an equation in y equals form. So we already know that we could write this as x equals 3 to the y, but that's not how we typically write them because it has to be in y equals form. So how we can write it is log base 3 of x equals y. And that's how we would say it. Log base 3 of x equals y. And that is the end of that section. So just go ahead and make sure if you need to rewind, pause, and then check your solutions.